Good morning. All right, good morning. Happy Friday. Don't forget that Monday is a holiday and there is no school. And I don't know if you already heard, but I had a meltdown in third and fourth period because people didn't have their videos on, and I actually shut my video off for about 5 minutes. So I'm just warning you that if I show my video, you need to show your video. Otherwise, I will shut my video off throughout the entire lesson. So I'm really over it. I think it's disrespectful, that you don't show your video if I have to show my videos. So make sure you have your video on. Otherwise, I'm going to be turning my video off. So at the beginning of the year, I wanted you to get in a routine of trying to get in a normal schedule, because this is your class. I know it's all weird and everything, but this is your class. And whatever you normally do, if you get up and take a shower, if you get up and walk the dog, if you get up and eat breakfast, I want you to get in that routine. All right. And so, yeah. Do you want you to show your video? Otherwise, I'm not going to show my video. See how that goes. You do have an exam on Tuesday. It's exam 1.3, 1.4. And I have been addressing a lot of questions with that. And I will today answer a few questions. What's going to happen in this, I'm not going to have a lot of time in this class to answer questions like I did for 1.3, 1.4. We just don't have that type of time. And the problems in this class are way too hard to take up that much time during class. So I need to use the time during class for instructional minutes. So it's important for you to get to know one another. It's important for you to work together. It's important for you to ask me questions when I teach the lesson. You can't ask me to do every single problem after the lesson. So on Tuesday, you will only take the exam. We will not be meeting during fifth period. I feel like the exam's enough. So the next time I would see you after the exam would be on Wednesday. All right. Okay. So today I am teaching a new lesson. It is on transformations of absolute value. Some of it's going to seem like we've already done it. I know you guys are tired. Just know I'm exhausted also. So we just need to hang in there. Okay. All right. Anybody want to ask me any questions about 1.3, 1.4 that's pressing on you that you need to know? Okay, well, you guys know the order of transformations. You know that? The order? Left, right, stretches and compressions, reflections up, down. You know what A, B, H, and K do to the graph of the parent? You guys know, odd and even? You know how to graph a line? You know how to find an inverse? You know the steps? Change f of x to y, switch x and y, solve for y, change y to f inverse of x. You know how to verify by composition. And let me just say this about the exam. This morning, my pre-cal class took an exam. And there's about 5 of them that sent me a reminder saying, Miss Birch, can you check my problem number 3? Can you check my problem number 9? Can you check my problem? Because they believe that they did these problems right and the program marked them wrong. Now, in some cases, they did do it wrong. But in some cases, they did the problem right. The computer was just expecting it to be written a different way. So I will give them credit for anything they did correctly. I will give them credit. So what I'm trying to tell you is when you take this exam or any exam, if you think you did something correctly and this computer program marked it wrong, make sure you have me check it. Okay, because we want to make sure you get credit for everything you did correctly. Okay? All right, last call. Anybody want to ask me about any problems for exam 1314? Today we're going into module 2. And if you notice, I sent out posts for the answers for module 2. I sent out answers for a sheet. It's called Review for 2-1 Test. And I also posted the lesson 2.1. So the California Common Core standard for this is F-IF.7b. And we're talking about absolute value. Now, with absolute value, the parent looks like this. So if you see any function that looks like something with bars, it's going to look like V, not a parabola. And if we want to get the parent points for this guy, we could just make a table in our head, or we could write it down. I'm just writing it down because people were confused last period. And put in any x's you want. So I'm going to put a -1 in. Do you guys remember the absolute value? A positive always comes out. So the absolute value of -1 is 1. Put in a 0. The absolute value of 0 is 0. And the absolute value of 1 is 1. So they happen to be the same points as the parabola. Now, square root, he doesn't have the same points. Cube root doesn't have the same points. But the parent points of the absolute value are the quadratic points. And the parent points, remember, are the points that we start with. Just like you started from your parents, right? These graphs start from their parent. All right, so we're going to graph left 1, up 1. We're going to graph 0, 0, and right 1, up 1. And instead of drawing a parabola, we're drawing a V. So that's what the graph of absolute value of x looks like. In the materials section in classroom, I wrote the forms for form number 1 and form number 2. So I want to show you what those are. So form number 1, you already know. I wrote it a little bit differently, but it doesn't matter. It's the same thing. So the last time you saw me write form number 1, I used B, but I don't care what you use. In this section, they're writing 1 over B, but it means the same thing. It's a horizontal stretch or compression. The second form looks like this. Now, the first question is, can you tell the difference in the two forms? Because in this lesson, sometimes they give you form 1 and sometimes they give you form 2. And if you have form 2, you have to follow a different order. So go ahead, unmute yourself and tell me. What is the difference in those two forms? Go ahead, I'm listening. What are the difference in those two forms?
First, you have to start off with x minus h since it's in the parentheses.
Yeah, this is in parentheses. That's all I want to know. So I want you to be able to recognize that the second form looks like that. Okay, so everybody turn to your book on page 71. Page 71. Okay, problem number 1. Does that look like the first form or the second form?
It looks like the first one.
The first.
You're right. Yep, you're right. Good job. What about number 2?
First.
We've always been using, right?
Mhm.
Right? Okay. Look at number 3.
The second one.
It's the second. What's the
And
second
because
form?
it has, like April said, it has parentheses, right? So guess what? For 3 and 4, you don't want to follow our regular order. You want to do this. You want to do stretches and compressions, and then reflections, and then left or right, and then up or down. And if you don't follow that order, you could get the wrong graph in the future. Now, if you're sitting there going, you know what? I don't know why she's pushing the order so much. I don't follow the order and I get the right graphs. Don't ask me to come to your rescue in the future when you don't. Because there will be a future and there will be problems where if you don't follow the correct order, you're going to get the wrong graph. So let me say this much. If you don't want to follow the order, that's cool, but you got to tell me when the order doesn't matter. And if you can't tell me and you don't understand that, you better follow the order. Now, the next thing is, I'm not going to say an argument. I'm going to say a discussion with one of the teachers. Because one of the teachers said, why don't you just teach one order? Why are you teaching both orders? And I'm going to show you why. All right, you ready for this? All right. This is the second order, right? But look what I can do. I can change it to form 1. I can change it to form 1. Watch. Cool. So state the transformation. Right to horizontal compression by 1/2, right? Right to horizontal compression by 1/2. That was cool. You want to distribute 1/3? You want to do this? No, we don't want to do that. So that's why I'm teaching the second form. So this is going to make the transformation difficult to do because we're going to have to when we do the point transformation, we're gonna have to add and subtract fractions. So look at this. State the transformation. This is the second form, right? So follow that order and state the transformation.
Vertical compression by 3.
Hold on a minute. Hold on. Is that a vertical or horizontal?
Horizontal.
It's inside the bars, right? A vertical compression would be outside the bars. So this is a horizontal what?
Stretch.
Stretch.
Horizontal stretch.
Horizontal stretch by 3.
By 3.
Horizontal stretch by 3.
And then right 2.
Right. And that was way better than doing this. So that's why I'm giving you the second form. So here's the moral of the story. If you want to multiply it out and it turns out nice like this one, go ahead. That's what I do. If it doesn't turn out nice, use form 2. Does anybody have any questions about what I'm saying? So like I told the teacher that I was discussing this with, I think if I give another order, the students will remember the order. All they have to do is remember the order. Rather than going through this, I'm not going to have you go through that. Because remember what I said, we're just eating baby food right now. This is nothing. So when things get harder, we don't want to deal with all those fractions. Okay, so just remember, when you have form 2, you can change it to form 1 if you want, but if it's difficult, make sure you just leave it alone and follow this order. Let's do a problem. So we're going to do a transformation of absolute value, but it's really nothing new. You already know how to do it. So we know that that is a V. And how do we know it's a V? Unmute yourself and tell me, how do we know that's a V?
Absolute value.
So state, is this form 1 or form 2?
Form 1.
Form 1.
All right. Okay, so what, state the transformation? Go ahead. We did like 30 of these. Before I started teaching 1-3, we did a whole bunch of these. What's the order? All right. Well. You were able to state the order there. It's the same exact thing. So how do you do the order? This is a V. This is a quadratic. A, B, K are still the same. The order's still the same. State the transformation, please, someone.
Right
Vertical
5.
stretch by 4.
That's correct.
Vertical stretch by 4.
Yep.
And down 2.
Yep. Thank you. We did a lot of those. But don't forget it now, because I told you. You're going to have to do this like 20 times in 20 different sections of the book. right means X, right? So add 5, add 5, add 5. Y stay the same. Vertical stretch means Y. So the X stays the same. And we multiply the Y by 4. Down means Y. So the X's stay the same. And we take a -2 to 4, -2, -2, and there's your points. This isn't new, right? I mean, this is what we did. You already know this. I haven't taught one thing new yet. Except this looks like a B. That's all I've taught that's new. This is exactly what I've already taught. So we graph the points, right 4 up to. Right 5 down to. Right 6 up to. And you draw a V with arrows. Now let's just see if this makes sense. Does it look like it was shifted right? Yes, it does. Does it look like it was vertically stretched? Yes, it does. Does it look like it's been shifted down to? Yes, it does. Nothing new here, except the graph is a B. Everything inside is horizontal. Everything outside is something vertical. Questions, or can I erase it? Can you guys unmute yourself and just tell me I'm okay? If you're okay, I'm all right. You know,
I'm okay.
Okay. I'm okay.
Okay.
I'm okay.
okay. Is anybody not okay? So every single person is going to get these right on the exam for the parabola. Let's do another one with the second form. Do you want to put? I don't. So we make a decision to use form 2. So what's the order?
Horizontal stretch by 2
That's correct.
and right 3. Or no, wait, no, right 3. Right 3.
Yep. That's correct. So we notice absolute value. We know this is going to be a V, and we know our parent points are left one, up one, 0, 0, right one, up one. They're like the parabola, right? So horizontal stretch means X. So multiply the X by 2, multiply the Y stay the same. X. So you're gonna add 3, add 3, add 3, and the Y stays the same. So 1, right 3, 0, right 4, up 1. It's kind of hard to tell this one, but it is horizontally stretched.
Ms. Birch.
Horizontal, multiply by 2.
So for the last one, since you're adding 3 on the with the 1 comma 1, wouldn't it be 5 comma 1?
I
Since
don't
you're
know.
adding.
That doesn't look right over there. So this does not look right to me because it looks like the parent just shifted right. So let's look at what you're saying. So horizontal means multiply by 2. So I think that's right. And then right 3 means the X, right? So that the Y stayed the same, but right 3 would be 1. Right 3 would be 3, and right 3 would be 5. Did that fix what you were saying was wrong?
Yes, it did.
Okay, thank you.
You're welcome.
All right, now right 1 up 1, right 3 0, right 5 up 1. Okay, now does that look like it was stretched? Sure does. So that's what I'm saying. When you do a graph and because right away it didn't look right to me. It didn't look like it was horizontally stretched. It made me want to recalculate. And then one of you guys brought up the fact that something was wrong. And then it shifted right. That looks right. And don't forget that when you're in Form 2, you follow that new order.
Do you guys want it or not?
April, your mic's on. Okay, can I erase this? Okay, now, just like we wrote equations with the parabola, we're going to write equations here. I think I'm going to do the easier problem first. Let's do the easier problem first, okay? So remember, they're going to give you a graph and they want you to write the function. And this one's 0 up 3. Right 1 up 6. And right 2 up. It up. It looks like it's been reflected over the x-axis and shifted up, but we'll see. So in the book, they will give you the function. So they will say, use this function. And it just so happens it's the second form. And they will also tell you that either B is 1 or A is 1. Now, when A is 1, the problem is easier. I'm sorry, when B is 1, the problem is easier. You have to find A, it's an easier problem. So we know for sure this is 1 up 6, and this guy is 0 up 3, and this guy over here, they don't give it. 2 up 3. So we know the vertex is the same as the parabola. It's 1, 6, which is HK. So we know what H and K are. And now I think we're ready to do the problem. So I'm going to use the point 0, 3, but when I do this problem, I'm going to do 2, 3, 2 and show you you're going to get the same result. So my new function, and I'm not going to skip any steps because we had a lot of problems last period. So remember, this is X and Y, so we're going to compute G of 0. So A, we don't know. Absolute value of 1 over 1 times X, which is 0 minus H, absolute value plus 6. Y. This becomes absolute value of 1 times negative 1. So Y, we're now changing to 3. So 3 is equal to A times absolute value of a negative 1 is 1 plus 6. So 3 equals A plus 6. So if you subtract 6 from both sides, you get A is equal to negative 3. Now, last period, I skipped some steps and they were completely messed up. So I showed you every little step here, that when X is 0, G of 0 is Y, Y is 3. Whenever you have A sitting on a parenthesis or absolute value, you are multiplying. The absolute value of negative 1 is 1. So you get 3 is equal to A plus 6 from both. Negative 3 times the absolute value of 1 over 1 is just 1 times X minus 1 plus. So the reason why I didn't put the 1 over 1, it's redundant. So you should know that 1x equals x. Okay, now I'm going to use the other point in a minute to show you that whatever point you pick, you're going to get the same function. And I do have confidence about this because this is right 1, vertical stretch by 3, reflected in up 6. And just in my head, it looks like this graph in my head. Okay, do you want to ask me about this one? Or can I do the other point real quick? Can I erase this? So let's say I didn't want to use 0, 3. So I want to use 2, 3. You would now do f of 2 is equal to A, we don't know, times the quantity, in this case is 2, minus 1, absolute value, plus 6. This should be g of x because it's a new function. So remember, g of 2 is y. This is a. This ends up being 1 times 1 plus 6. Y is 3. So this becomes a times 1 is a plus 6. Subtract 6 from both sides, a equals -3, and you get the same function. All right, anybody want to ask me any questions? I'm gonna do one where we have a is equal to 1 and we have to find b. It's a little more difficult. Can I erase it? Okay. So in this one, they give right 2 up 5. I gotta move it down. In fact, let me just draw it over here. Okay, so they give right 2 up 5. They give right 6 up 6. And they give left 2 up 6. So it was either horizontally stretched or it was vertically compressed. And so the vertex is right 2 up 5, and this other point 6, 6. You can use that point too if you want. So they give you the function. And they tell you to use this one. That's the second form. And you have to find A, B, H, and K. And in this problem, they tell you A is 1 and you have to find B. So the vertex is right 2 up 5. And I think we're ready to go. So we're going to do f of x is equal to A is 1. So there's a 1 there, which is redundant, times 1 over B times 2 minus 2, that's not right. X, 2, 5. I'm using the vertex, so see how it's not gonna work? So we don't wanna use the vertex. We wanna use the other point. So see how it didn't work? Yeah, so right away, there's a problem. So this is our X and Y. So we wanna do G of 6 is equal to A is 1 times the absolute value of 1 over B times the quantity 6 minus 2 plus 5. So remember, G of 6 is Y. That one's redundant, so I'm just not going to write it. We don't have to write it. Just like 1x is equal to x, that 1 is there. We know the 1's there. So this would be 1 over B times 4 plus 5. So now we know our Y is 6. This ends up being the absolute value of 4 over B plus 5. We're going to isolate the variable. We're going to isolate the absolute value. So we're going to subtract 5 from both sides. And we get the absolute value of 4. Does anybody have any questions so far? All right. When you solve an absolute value equation, you have to write a compound sentence. So, to say it simply, to get rid of those bars, you have to show the positive case and you have to show the negative case. So that absolute value means that. The positive case and the negative case. So if we were going to solve this thing, show you all the work, we're going to multiply both sides by B so that we can find out that B equals 4. And I'm going to do the same thing over there. I'm going to multiply both sides by B so that B equals negative 4. And since that graph, I think I erased it, since the graph doesn't look like it's reflected, we don't have to use the negative case. And so what do we get? We get G of X is equal to A is 1, which is redundant, 1 over 4 times X minus 2 plus 5. Okay, so that time I showed all the work. Because in period 4, I skipped a bunch of steps and everybody was confused. So all I'm doing is solving an algebraic equation. Do you guys want to ask me any questions about any of the steps? Well, when students are totally silent, it means one of two things. Either you all get it or you're all lost. So which is it? Okay, give me some feedback on a scale from 1 to 10. With 10, you totally get it, or 1, you're just completely lost. Where are you? So please share with me, where are you with this?
Probably like an 8.5.
Okay.
Let's say a 7.
About 8 to 9.
9.
An 8.
Yeah.
Like an 8.
If you're a 7 or higher, what that tells me is you're okay, because you can look at this and figure it out. Like, you may not know it right now, but you can look at this and you can figure it out. So the 7 is not bad. Okay, before I erase it, does anybody want to, so whenever you're missing B, it's going to be this type of thing. So anybody, and by the way, this situation only happens with absolute value. It's not going to happen with square root. It's not going to happen with logarithms. It's not going to happen with rationals. It's not going to happen with anything except absolute value. So absolute value translates to a compound sentence, and you have to consider the positive case and the negative case. Okay, anybody want to ask me a question before I erase it? That went over better than I thought, so that's good. Maybe I just taught it better this period, I don't know. I'll have to make sure to upload this video. Okay. So we have some time right now. So what I am going to be switching up the teams pretty soon, basically after this exam. But what I'd like you to do is I would like you to go into your teams, and I do want you to collaborate and talk. I want you to start on lesson 2.1, and you're going to start with problem number 1. Now listen carefully so I don't flip out. I want you to start on page 71, number 1. You are to say the problem out loud, the transformation, show the point transformation, and graph. And you're going to be doing that in your teams because I'm going to kind of evaluate you. So I'm going to assess you on this. So don't be doing anything else. Okay? And I'm also going to take attendance. So it's 11:39 and class is over at 12:10. Make sure you do not leave class before 12:10. Make sure you send me a remind if you need me to come to your group right away for some kind of question. Okay? You will not report back today. So you'll be leaving class at 12:10. Good luck on your exam on Tuesday. I hope you all do well. And I will be seeing you on Wednesday, right? All right, good luck on your test. And I'll see you in the teams. Okay, I'll see you in the teams.